Good morning, Your Holiness. We began the week with quarks and quanta and qubits and entanglement, and then we moved to cosmology. Yesterday we spent the day on consciousness, and today we will move to focus on evolution, and we will revisit the issue of randomness as it comes up in evolutionary theory. And we'll then also move on to the topics of altruism and compassion, which Your Holiness has underscored as so and emphasized as so important. We're very fortunate to have Ben Shapiro with us. Ben is a board member of the Mind and Life Institute and is a biochemist and a physician by training. And we'll begin this morning by talking about evolution and randomness and how it may be related to altruism. So with that, I turn it over to Ben.
Good morning. Good morning, Your Holiness. Yesterday, Wolf Singer gave a beautiful talk and told us about several things. He told us about consciousness, but he also told us about the use of evolution as an absolutely fundamental part of the infrastructure in thinking about any aspect of life. And we believe that that is a key component that our knowledge of life is built upon. As a key component, we want to be sure that it is a strong part of our foundation. And thus it's appropriate to see whether this foundation can deal with all the issues that we learn about as we study more about the living state. And for that reason, I was delighted to read in your wonderful book, chapter on evolution and karma and sentience, because you raised several points that we need to think about as biologists who seriously want to pursue this model. And I'm delighted to have the opportunity to respond to several of the points you made because I thought they were so important. And I consider it an honor and a pleasure to have the opportunity to do that. Anything that we talk about in the environment of evolution, I think needs to be approached with this perspective that you gave in your book. Whether we see ourselves as random biological creatures or as special beings endowed with consciousness and moral capacity will impact on how we feel about ourselves and treat others. We are doing this activity to relieve suffering, and it's important that we keep this in mind, especially when we talk about evolution, because ideas of evolution have been used to support many types of behaviors, some of which have spread across the political spectrum, across the social spectrum, and in fact, as much as it has provided information and support for our understanding of biology, certain interpretations of evolution have increased suffering for certain people because of the issues that were put on the table. So this is an extremely important area. This is the one grand theory of biology, and we have to see whether this theory is appropriate. And your challenges, I think, were, to me, very, very much on point. So I want to talk about the two qualms that you raised. The first one, the two reservations you raised. The first is about completely random mutations providing the variation needed for evolutionary change. And you say, from a philosophical point of view, the idea that these mutations, which have such far-reaching implications, take place naturally is unproblematic. But they are purely random strikes me as unsatisfying. It leaves open the question of whether this randomness is best understood as an objective feature of reality or as indicating some kind of hidden causality. It's a very
근데 대왕 그냥 시대보다 세대 됐을 조금은 더 지다 랑싱 충분히 됐을라면 교요 말했어. 대왕기 충분히 살도 교면
And this reservation deals with one of the central pillars of evolutionary theory. The creativity in evolution is the variation that comes about by mutation. That is what leads to all the opportunities that exist. And I think we need to consider what is the essence of that mechanism and to think seriously about points that you raised, such as this. The other reservation, the other qualm you had, was about natural selection and competition for reproductive success being the driving force for evolution, and the inability of that to explain altruism. And you said the inability or unwillingness to fully engage the question of altruism is perhaps the most important drawback of Darwinian evolutionary theory. Why does modern biology accept only competition to be the fundamental operating principle, and only aggression to be the fundamental trait of living beings? Since humans have a dangerous tendency to turn the visions we construct of ourselves into self-fulfilling prophecies. A very important point.
그래서 라고도 말아줘 뭐 간대에 삼삼지 문제 제가 돈에 아니 줘봐다 지금 다외 계속도 줘볼 때요
And this reservation deals with the other central aspect of evolution. If mutation is the creative part of the process, this is the editing part, the part that determines what ends up in any pathway of evolution. And here you're raising a fundamental challenge that says that maybe this doesn't apply in every area. Maybe we can't use this as our foundation in this area. These are very important points. First, I want to say a word about natural selection. There's no question that selection works. I mean, we know that just by recognizing that starting with a wolf, you know, in hundreds of generations, we have generated many different types of dogs just based on human interest in mating animals to achieve a result. And so there are all kinds of dogs, many of whom we heard last night at 4:30 in the morning in Dharamsala. But nonetheless, this in any event, clearly selection works. The question is, what is the domain in which natural selection can work? So I'll come back to that, and I'd like us to look at to step back from the biologic aspects of Darwinian evolutionary theory and look at it as an abstract concept, because I think that's a useful place to start. Darwinian evolution is really an optimization hypothesis. And it deals with
music songs telea tega dajer membeche the music tandalia ani mangbushi buji pungje entene yagas tamyarje optimization.
So it deals with the fundamental idea that if the environment changes, there are new causes and conditions. How does one adapt to this new causes and conditions? What can one do to be appropriate in the new environment? And you can imagine two extreme ways of dealing with this. One way would be to take the best intelligence that there is, optimal intelligence, and take the best ideas and design the best system for this new environment. And that would be one extreme. And another position would be to say, really smart. Pick the best way to go. And that's a reasonable way that one might do it. Another reasonable way would be to say, I don't understand everything about the new environment. It's a complex environment. It has many causes and conditions. And so, because I don't understand it, I can't make the best thing. I will make as many things as possible. Test them out. See what works in that new environment. These are two general ideas about how one might approach change. It turns out that Darwin, in looking at what had happened in the previous century of biology and of study of fossils, and from his own careful observations of the geography of animals and aspects of development, Darwin said, what happens is really number two. This is the path that biology has taken, that there's variation that occurs, and then these variants are tested in the new environment. This was actually an amazing idea, because in a sense, this was done in the absence of everything we know today, 150 years later, about biology. He didn't know anything about genetics. He certainly didn't, because Mendel hadn't done his experiments for 2 decades, and Mendel's experiments on genetics weren't really appreciated until the beginning of the 20th century. It was 100 years later before Watson and Crick discovered the structure of the gene. And now, 150 years later, we know much about gene sequence. Francis Crick, the co-discoverer of the gene, said, evolution is cleverer than you are. We have no need for this hypothesis, the first part of the hypothesis. That is not necessary to explain what happened in biology. That is extremely important. And we don't need to look at the fossil record or at animals themselves or the development of animals. We can look at all of those. We can look at the genes in the animals and see the relations that exist between all living beings. It is remarkable to me that Darwin put in place this fundamental idea that has been supported by 150 years of biology and genetics, and every aspect of this, in its overall function, has been supported. So although we speak of a theory of evolution, we also have a theory of gravity. But everyone knows what's going to happen if I open my hand. So consequently, we probably understand evolution better than we understand the mechanism of gravity. So it's a theory in the sense that we keep understanding new issues about this, we're refining it, and refining it in light of some of the questions that you raised. So let me go back now to your first question. Can variation really be random? And to discuss this, is mutation really going to be a random process? Or is there some type of hidden causality? This phrase, hidden causality, was extremely provocative in several senses. It was it's provocative in an interesting sense, in that it certainly made me, and I think other people, think about what types of issues might be in biology around the idea of hidden causality. In a less serious sense, in a more bizarre sense, it was provocative of behaviors in America that I want to tell you about briefly. In America, we repeatedly encounter interactions between people who feel that their lives have been damaged by the fact that that Darwinian evolution says there's no need for a creator God to have made them in God's image. And so Darwinian evolution has no need for the hypothesis of a creator or a creation. Some people interpreted your phrase here to indicate that you might have thought that there was a need, that this hidden causality meant some creator in the background. This, of course, is a ridiculous idea because it's against everything in Buddhism. It's against everything you said in your book about where you dealt with the issue of a creator. But yet, reviewers of your book referred to this in the sense of who is behind the scene pulling the wires, and His Holiness, who believes that science is preeminent, is suggesting something like a creator force in the background. And Mathieu was contacted by people from the so-called intelligent design movement who wanted him to sign a petition, since it looked like Your Holiness had supported the idea of there being some intelligent designer up there pulling the strings, and they thought they could get support.
일단 아릴리아 지금 제법을 요밤에 나왔지 치수야 체리나 다워르비스 인텔리전스 디자인스라고 간다도 로이요 원도 나와 다라래 로이요 원도 나와.
So this is ridiculous. But on the serious side, I thought this was an interesting idea, and I wondered what you meant, and I want to tell you what I think you meant, and then I will ask you what you actually meant from that. So.
나 근데 히든 코사를 주 응외쌤 저거 매든지 용서 그래서 간다고 봤어. 코란 게 섬지 구두 공부 가와시에 변나서 저봐 지기 디슈 컨디슈 is. 그래서 구두 렐 공부를 봐.
So there's insights from modern molecular genetics about mutation that are important in understanding this. And when I tell you this story, I think you'll see that I was quite impressed at the intuition you expressed in this statement about hidden causality, because there really is more to the story than the idea of random mutations suggests.
뮤테이션을 교화돼야 돼. 지금 대왕의 교화돼야죠.
When biologists speak about randomness of mutation, we're not speaking the way physicists are. What we mean is that mutations are not directed to make a specific end product. In other words, mutations occur throughout the genome, but they're not directed toward any specific structure. We do not mean mutations are without a cause. Mutations have a cause. The cause may be radiation, X-rays, ultraviolet radiation from the sun. The cause may be chemical. Every time a cell divides, the code of the DNA has to be copied, and errors are made. And so those errors are a source of mutation. And then we have enzymes that copy the DNA, and we have other enzyme systems that correct these errors. Even so we have, in general, our genome, our genetic composition of us is really quite stable. But, and this is the intuition that you had, I think, despite the overall stability, the capacity exists to have mutations that are directed to specific cell types at specific times under specific needs. And to me, that speaks to the issue of hidden causality. There's more to the story than random mutation. Something regulated is going on. So mutations are more complex than the simple-minded idea of them is, and you picked up on that in your comment. And in fact, the kinds of mutations that occur can be quite dramatic. One principal form of genetic change is to take a piece of code from one place in the gene and move it somewhere completely different, as if you're cutting out a piece of information and placing that information elsewhere in the genome. And this is done, it can be done in a regulated fashion. And another biologic event that can be regulated is to increase the rate of mutation the amount of mutation at a specific site in the gene. And I want to give you one biologic example of that because it shows this, and it actually shows a process of evolution that occurs in our bodies all the time. It's a real process of evolution. It turns out that we produce proteins that are called antibodies. And these antibodies are directed against disease-causing agents or foreign agents. Viruses, bacteria who invade our body get bound by these antibodies and they get removed by one mechanism or another. They get removed. This is a very important part of our life because people who do not have this capacity die young of infection. So this is a very, very important part of how we can remain alive when we're surrounded by many types of infectious organisms. It turns out that we can make antibodies against many types of organisms. We can make billions of different structures of antibodies. We do not have enough code in our DNA to make billions of antibodies if all the DNA was just used for making antibodies.
Can you repeat the last?
Yes, this is an important point.
Yeah.
We can make billions of different protein structures as antibodies. There is not enough information in our DNA to make all those different structures. That is an interesting paradox.
Information. So what do you mean by not having enough
Well, I'm going to explain
information?
this to you. This is hidden causality.
Are you going to?
This is what this is why I thought his intuition was really very interesting because it's a very complex story. So remember that most of our DNA, most of our code is not used for antibodies. It's used for all the other things to make your holiness and me and our hands move and everything else. But yet we can make billions of different structures without that information content in our DNA.
Ben, I'm here.
I want to explain that.
Could you just, I'm not sure if you're going to explain this. Just explain exactly what you mean, how DNA is used without going into the details to make an antibody.
Let me briefly remind you that DNA is a code. That code tells what the structure of a protein will be. So we need information. The DNA is information. It says, make a protein of this structure. Okay. A certain amount of code is needed to make a specific protein. If I wanted to make anything, I would have information about that, and then I make that thing. And that's all this is. But we can make billions of things, antibodies. But in our original genome, we do not have all that information.
And antibodies are made out of proteins.
Antibodies are proteins.
Are proteins.
So in other words, we do not have enough information. When we get genes from our mother and father, we do not have enough information in that genetic material to make all the antibodies we will need to make in our life. That's a very important point.
자기는 좀대로 지고 와라. 양진 교원도 돼야지. 다 주민은 인다 더 코스트리 거다.
네.
그렇죠. 지다다 뭐변도 다 치베이나.
간데슬로.
그럼 뭐변도 다 치베이나. 근데 제진도 지고 와네. 교원도 중국에 있으니 땡케 줘 봐라.
네.
다 땡케 다 제진이도 마시면 맺지.
네.
마시면 이나데 더 페퍼도 기샤.
네.
다 몽바리 디셔비나.
네.
다 오가다 그 차상벽에 통돼야지. 통돼야지고 아니 지 다시 다다봐 되는 신 죽음에 되시.
네.
다시 더 페퍼 차상.
네.
당 아주 더 페퍼 사디 시장 상황 시에서 그만 레스 거다.
Generally, the principle of postulating a third factor operates like this. So imagine a set of circumstances where you have all the factors, causes, and conditions, and if the assumption is that these factors that are gathered here, the causes and conditions, these have enough. These are These are the totality that would give rise to us, say, an event. Yet, despite that, if the event, it cannot give rise to the event, then we have to, biologically, by means of logic, determine that there must be another factor that is necessary for the production of the effect. But when His Holiness was saying that in his case, he didn't have that kind of intuition you are suggesting, he meant karma.
No, that's okay.
There's no secret to us. It's karma for us.
This is sometimes on the temperature. Semi-pembu-zag. That would you do as well. That dinnerly and the same thing that zag, that pembu-zag on the 차상 두긴 차상 독스잖아. 좀더 비지글. 딱 거기 먼저 비준 되잖아. 딱 내게 시야로 당. 다디 세미 펜불라에 다가는 시. 남준저 새끼야 돼. 자가 누구로 차상 좀더 찍라. 양고 먼저 해야지. 용거야나.
나래.
마시란다. 세미 펜불도 이디에 야 또윤준다 그런 게 시야는 시야. 지금 롱저버 semjen기다 라드 더이도 샤샤거로.
나래.
용거야 보다. 용거야 봐. 그래서 이내도 지다 그러나 세미 펜불 균제근 도단디 그런 중의 취닉으로 다로 배지레마도 도와 다 샘데 규규 뒤에 다 직속적인 그 균제근 도야 디나로 배낭에 자신 좀부터 것에 넘버 시바 디우여나 야 패널로 직 그다 도어로 직 디우면은 도어로 직도 세브로 되기도 와 다디 세미 펜불이 야마
So generally, you can see a contrast in the cause and effect processes. If you, from the Buddhist point of view, if you contrast inorganic matter on the one hand, and a living organism, especially a sentient living organism of a sentient being, such as the human body. Within the human body, within the cause and effect complex, from the Buddhist point of view, you observe phenomena where the causal account purely within the physical domain doesn't give a full picture. Therefore, we attribute or we postulate a third factor, such as consciousness. And
I think obviously, usually we, of course, I think from the
earliest stages of development,
we usually use one simple word: lucky, unlucky. So that means, we can't just explain. We plan everything, almost 99% sure, no, this will happen. But then something happen, then usually we simply answer, oh, unlucky. So then there must be some causes. So that is the genetic, the subtle country, the Kurang Chisha, the semi-pem, that is the semi-pem, sometimes.
So His Holiness is, and then he gave an example. For example, like we know from our, first-person experience that the state of our mind affects even our biology in a physical.
I think generally, the life with consciousness or mind, that is like human being's body. Then another, the plant, this life, and these small things which are working there. In order to change, in order to survive. So on that level, more or less same. But in our case, these the cells can affect by our emotion, happy mental state. These functions go smoothly. Unhappy, a lot of stress mentally effect on these cells. Outside, no sort of mind, we call no mind, then that part is not there. However, now this, whether it's the same or not.
So the question is, sorry, I was thinking His Holiness was thinking of inorganic matter, but he is thinking actually of living organisms like trees. And so this is the divide between the sentient and the non-sentient. So imagine you have plants and other living organisms. Contrast that with a sentient body. So in the case of the sentient body, as His Holiness pointed out, it is clear that our state of mind has an effect on the biological system. For example, if you are happy or unhappy or stressed, it has an effect. So in this case, we can understand the complexity you are pointing out. But would you say this phenomenon that you're referring to this gap, discrepancy between the information, lack of inadequate information, but ability to produce this. Does that exist also in plants?
Yes. Let me respond to that. There's several things I need to say about that question, which is, of course, a good question. First of all, I'm going to tell you how this works. This is a paradox, but it's an explained paradox. So in a moment, I will show you how we can make more antibodies than we have information for in our genes. I will explain that. But secondly, it is true that this is going to involve a set of events that occur. And if karma were going to interact, it would need to have some place to interact. And that gives the substrate where something like karma could interact. Certainly, you're correct that our emotions affect the chemistry of our body and the chemistry of our cells. And that's unambiguous that can happen. It is possible that something like that can happen in the immune system. There are many people who believe that aspects of the immune system are affected by emotional state. So all of that is true. The issue of whether plants and animals are different biologically, fundamentally, the way they are to Buddhists.
Not animals.
Plants.
Plants don't have immune systems like this. And later we can, maybe in the afternoon discussion, talk about sentience in that setting when we hear the multiple different takes on the psychology involved around this. But I'd like to defer the general conversation on sentience in plants and humans.
Immune system?
Immune system.
Does an amoeba have an immune system?
No.
Oh.
Lower animals have different types of protective systems. There's a
His Holiness is wondering whether what you're pointing at may be a potential basis for empirical division of what is a sentient and non-sentient.
We have other ideas.
Let me say that we have many ideas about
something can move by itself
Yeah.
From some distance. That at that time we concluded sentient being.
But bacteria, Your Holiness, bacteria could do that.
Bacteria can swim, and they swim away from aversive.
But we have to make distinction. It's some movement due to other chemical.
Yes, right.
Or some without
Based on
chemical,
decision, yeah,
but itself.
Yeah. Okay.
So some differences. When sperms, I think sperm movement, I think due to other chemical, maybe.
It's true. It does do it. I used to
So
study
that not necessarily
Right.
its own sort of capacity.
Right. Motivation. So anterior singular, basically.
So the virus is very different.
No. And the machine sentient and non-sentient community in Nguyen.
So I'd like to defer that issue until we have the rest of the thoughts on this. The issue of sentience versus, at least from our biological perspective, because we have more information to bring to that story. But to continue in this, how do we make more antibodies than we have the coding capacity for?
Plants antibodies are
So there is no antibodies in the plant.
They have a more basic protection system. They can change the surface of the plant. If a foreign organism invades a plant, it can make a scar. So it does have protective mechanisms. And many different animals and plants have protective mechanisms that are less subtle than this. This is a very complex system, and it's basically, this is a fundamentally mammalian attribute of making antibodies. So the way this happens, this is going to be a little bit of complicated molecular cell biology, but I think it's an interesting story. From our parents, we have this is a whole gene we get from our parents. This is the structure of an antibody. This is a protein. And this is a cartoon. The blue part we can forget about. That has to do with how antibodies function to get rid of organisms. The part we're talking about is why we can recognize so many different things. We can recognize 1 billion different things. The recognition is done in this red, yellow, and green part of the molecule. And the way we build our antibody system, the way we make the cells that make antibodies, the B cells, is when we, as fetuses, still in our mother's uterus, we start making the cells that will become B cells. And each of these cells is made by taking one of these red genes, one of the green genes, and one of the yellow genes, and putting them together. We cut them out of our parents, of the gene we got from our parents. We cut a unit out of red, a unit of green, and a unit of yellow. And we put them together. Every B cell randomly picks one of about 50 red units and maybe 10 or 20 green units, maybe 5 or 10 of these. Just the way you could build different cars out of modules. You take a body of one engine, a different steering wheel maybe, or interior. So this is a modular assembly by cutting out pieces of DNA and putting them together. So we make one antibody. Let's say we took this red one to make this protein, red part. We take this green one and this yellow one. And that makes one type of antibody structure. We don't need to worry about the chemistry that does that. That's known. But that makes one antibody. And one early B cell will just have one antibody. So this gene is not expressed elsewhere in the body. This gene is only used to make antibodies, and it's made by giving different modules. If there are 50 modules here, 20 here, we can have 1,000 different types of structures, let's say, or 10,000 different types of structures, depending on how many of these there are. And although I didn't show it in color here, there's a second component in the antibody that also has the same variability. So this modular assembly, randomly picking these units, allows us to make 50, 100,000 or more different types of B cells.
So how many of which parts it's selected as random?
Okay, so this is, as far as we can tell, this process is essentially random. It is true that some of these modules are used a little more than others, but generally this assembly is completely random. We randomly pick one of these, and one of these.
So, but although the selection may be random, selection is done random, but it has far-reaching implications in terms of protecting the organism against
far-reaching implications.
So there must be some karmic sort of link.
Okay, so this is a step.
I think that's the time
where you could imagine
the karmic sort of involved.
Yes, well, we'll get back to that.
I don't know. Still mystery.
No, it's possible. But having a step process here, an actual cause, I mean, we're talking about a series of interdependent causes. These are interdependent causes. This assembly is dependent on all the steps of putting this together to make...
Randomness looks as one. This is a common to ya, they changing new day, they take him back, any one put the position, Mabuti the
Ben, His Holiness is asking a question. For example, we may call it random, but would you say that conceptually speaking, how many of the different units are selected? Are there any other constraints being placed from, say,
another particle?
Yes, so let's talk about these red ones. When people started looking as to whether this is completely random, they found that some of these were picked at a higher frequency than others in making the ultimate antibody-producing gene. So this is an area where you might be able to have another process take place, but we don't know anything about that process. So now we have a situation where we have these early B cells, naive B cells, but we have 100,000 different types of them, or maybe more, just by the random assembly of these structures. And each of these is unique.
Ben, just to be clear, so there is no biological explanations for why X amount of that modules were selected and why others are selected less. I mean, there is no. His Holiness's question is: are there any constraints being imposed?
So, as I tried to say, the constraint is that you need one red piece, one green piece, and one yellow piece for every gene to make an antibody. And there's some evidence that these are not used equivalently, but what causes that difference is not known. And the general point, which is... But the general point that His Holiness is making, that Your Holiness is making, is that this, having an event like this gives you a place where other interactions can take place. It is possible that something else could influence what is happening in this structure, because this is a place where something can actually happen. An event occurs. Chemistry happens. To get this information out of here, you have to cut this gene and paste it back in the structure to make this. So clearly there are places that karma or anything else could intervene. Well, let me now tell you how this actually works.
Anything else is God.
Yeah. Right. Which you got accused of saying. So we have now these cells. We have 100,000 of these B cells. I have 3 of them here. But there are 100,000 different B cells. Each of these has a different antibody on its surface made by this modular assembly process. Okay? So we accept that we have these cells, they have antibodies, and each antibody is different because of taking different information to put together to make the antibody. And we have 100,000 of these, let's say. This is not a billion, this is 100,000. But it's a large number, several 100,000, maybe a million. A virus comes in, and it has on its surface something that can be recognized by an antibody. The term is epitope, that doesn't matter. There's something that comes in. This virus then obviously is not going to recognize all of these randomly made antibodies. Only a subset of these antibodies will recognize the virus. When the antibody binds the virus, and information goes to that B cell and tells it to do 2 things: to start dividing and making more of this antibody and secreting it, and also to start mutating the antibody gene. This cell then begins an extensive process of mutation turned on by binding the virus. And it makes a mutant.
The virus laid the B cells the B cells the Tamil washing matters the Kodan Chilia called Jarugres. Jarug that the B cell don't learn of the Gris. Chick the Kura
Mangas over it.
Mount Diana. Chick the chronological information to Guatanja and commutate Jack.
Don't
let it handle.
So then antibodies, most of these cells aren't affected at all. They never bind the virus. But the cells the cell that binds the virus, and there are many of them, this is a simple example of, starts mutating and makes other antibodies, some of which won't bind the virus, but some of which will bind the virus much better. And if the antibody binds the virus better, that cell tends to divide even more. And so you have a feedback situation where you mutate, you make different structure of antibody, and you select. There's a selection for the antibodies that bind the virus best. And this process occurs after we're born. We're born, we get infected by influenza virus. In our population of naive lymphocytes, there are some that can react to that virus, but they're not very good antibodies. But they have a process now of mutating and being selected by virtue of better binding to the virus to make much better antibody. That process takes 2 or 3 weeks or a month to occur.
Virus kuna bisala yabojana. Kuna katse yabojana. Then manga drogere. The selection of the gana dying kejamari.
Mara ko jaya di ko kasuri pege 찬전을 지 주머니나 거북이 누구 숙제 입었을다. 찬전이면 그 교수 시에서 맞는다.
Maybe I think we need a little bit of clarity here. So among these antibodies that are floating around, virus comes in. So one of them binds to the virus. So what is the mechanism? Is it a chemical reaction?
So that
the virus is like a lock and key.
That's right.
The virus is like a lock. This is a virus coming in. This is the antibody.
That's right.
The antibody recognizes it and binds to
That's
it.
right.
Okay? If the antibody is attached to the cell divides, mutates to make some better antibodies, and secretes antibodies out into the blood. So you keep getting better antibodies by virtue of the early naive cell binding a virus.
But if it binds better, then it reproduces more.
Yes. Yeah, exactly.
The virus가 virus는 아마 숙시를 열어야 말이야. 숙시 열어야 말이야.
So imagine within the virus that are coming, can there be different degrees of force, powerfulness?
Yes, exactly. There are different degrees of force, and the better binding stimulates more of that antibody to be made. That's exactly.
So how does that selection work?
The antibody or
Not antibodies.
antibody. Antibody 그 virus 직접 채로고 줘야 그래서 좋아해.
So how does the antibody picks up on the virus that is most forceful?
Okay, so let's say an antibody binds weakly, and the cell attached to that starts making more of that antibody, and it mutates the antibodies. It causes mutations. So its children make different antibodies because it's undergoing mutagenesis at this site. Some of those bind better, and that cell does this even faster and better. And so the more potent the binding, the more stimulus to the cell to make that antibody. So it's a signal. If you have a good...
mutation che ani an tonlen che shuk chiru chinje du si je rimbar bjin do yar zla
virus ki shuki chechung mare virus ki shuki chechung mare de koran kanse yabu jag yore ki kechere
ko tambo yabu jamindo tene din nang le ta mutation che ra ta mutation ki di puku nang le ka she yabu ban ba ni che ra ta di mangbo shi so gre tene jema tamje yabu dang gre
당봉을 쳐봐셔서 그러시죠. 드네고 디나네 니 숙심부 담통에 중반나 너 코로나 껴도 리프레스 망부 제제.
바레스 코로나 치바 되게.
그래.
다디 바인딩 게 껴봐 용 그래. 뮤테이션 게 제라.
디 껴봐 가져는 거래.
다디 담보 코로나 숙 중중을 잡아라. 다디 바인딩 치도 가서 그런 뮤테 체고래 세고 시그널 나고 있단 그래.
그래.
다디 뮤테 체산에 다디 그 셀게 보고 나네 직 많이 야부 담그래. 다디 거 야부 도스인데 이양 망보체 그래. 다디 제마 바이러스 강갈라 좀 그래.
그 배려해서.
다음에 bet 맞잖아. teni 코로나 뮤테 제가 말에 만도 조금 말에 테스트 잖아. teni 코로나 뮤테 제그래 테스트 만도 조그래. 뮤테 제도 간에 코로나기 보고 나네 직 테스트 야급 자그래. teni 코로나기 보고 나네 양 테스트 야급 자그래. 다 bet yabu janken chungurva they bet mandu jogre.
So His Holiness was asking why does some of the antibodies bind better than others?
Because they have let's say you want to bind to my fist. The first antibody looks like this. Doesn't really bind very well. Some antibodies will be made that look more like this. The structure changes of the antibody. Completely different structure. The mutation leads to a completely different structure. And this is how we can make, by this mutation event, we can make many more structures than we have in the information in our genome. So it's the random assembly and the mutation that allows us to do this. Now, I took this long story because I felt that you had intuitively thought that a situation must be more complex than it seemed, and you were right. In response to the environment, there are well-controlled mutations occurring at specific sites in the genome, in this case to make antibodies. Specific controlled mutation. It's not random. It can be targeted, it can be well controlled, and that's how we make our immune system work. Moreover, and importantly, none of this is directed to making the best antibody right away. Lots of types of antibodies are tried out, and only the ones that bind the best pass the signal on to the cell to divide and make more of the antibody. So again, there's no guide in here pulling the switches. So this is very consonant with Buddha's thinking about causality. Now, I've given you, this is a true example of Darwinian evolution of an antibody. It's mutation and natural selection. Some scientists today think that this also has happened in evolution. And I should say that this is a place, obviously with all these steps of causes, there are many sites for karma to intervene. Some people think that this may also work in evolution because in our genes, I told you about the ability to cut out a piece of information and paste it somewhere else. 40% of our genes have structures that can be cut out and pasted elsewhere. Our genes are full of this capability of removing a big piece and putting it somewhere else. And when we look at other genes of other organisms throughout evolution, we see that this process of moving big pieces of DNA around has occurred frequently in evolution. So it looks like this may be a fundamental principle, and thus, I wonder whether you want to, you have done this during our conversation here. I wanted you to expand more about your intuition, which, those of us who participate in this meeting are always impressed with your intuition and your understanding of science. And in this case, you really got it right on. I mean, there is this hidden causality in the sense that I showed you of a much more complicated system that, in fact, is very well regulated, so that this gives us the capability of getting the variation for mutation. And is this the kind of thing you were thinking of when you suggested that you needed sites for the intervention of karma, the idea that there were places in this whole process where karma might intervene? I mean, clearly, this provides a structure where there are many intercession centers.
Biological process the Taiwan Chungshebe Guruata and the Damchen Chikok Ton and the Shejabina, Namshamamboji, the Shejab to Mabachita, Telia, Taiwan Slap to go to Genshin, Tampere.
Is this, were you thinking of something like this, about a system that would allow?
Yeah.
That's what it was, yeah. So that's what it is.
Yeah. There might be stages in the story, the causal story.
Dele Chao Jusin, they are the massive changes, they have young secret. That is Dele Chao, that you can send that Mindus, that you need to random Lavina, that self channel.
However, in the, for example, imagine the causal chain. However, there might be certain factors that could be playing, a causal role, which may remain
not yet found,
which may be opaque.
Absolutely
and not
true.
Found.
Another 10 years or 50 years.
This is
we may find.
This is 40 years of work.
Yes.
This is 40, 50 years of, and this is, many Nobel Prizes have been given for the work I just described, and we don't understand it completely. And it's interesting that some of those modules are used more than others. We do not know everything about this process today. This is a summary.
So His Holiness is saying that even the idea of saying that this is where the karma intervenes is a problematic one, because the biological story may still not be complete. There might still be factors which could be explained biologically, but which may not be, which may be opaque at this point in our knowledge of biology.
Right, and
But the point where karma would become relevant might be a point where you really run out of biological explanations.
Well, did it? That touches.
Yeah.
That's the large biological tone. The large touch that any like
So, for example, there might be causal processes where you feel that the biological account is completely, established, yet there are areas of randomness.
Of course, the biology is I understand the biology this is the status that we understand of the biology. not every detail is understood. I also understand that it's only in the Buddha's omniscient mind that we understand where karma intervenes. So I'm not suggesting that this is the pathway. Mathieu.
Yes, well, in a way also, generally we speak of karma as a particular subset of cause and effect, which has to do with consciousness and with consciousness with intention. And so if there's an intention of doing a particular act, it has repercussions in terms of experience too, happiness and suffering, which has to link with our own experience and the conditions in which we find ourselves. So we have a part of responsibility. We could say we are the result of the fruit of the past and the architect of the future. So we're always at a crossroad because it's part of our intention. So that's kind of clear in terms of human experience of happiness and suffering. Now, in this kind of biological process, of course, we still will have to find a way of explaining how this can act at this type of level. It's pretty clear in terms of our experience, like hatred causes suffering both to others and to oneself. Now, on the longer term of the explanation of karma, this obviously implies the continuum of consciousness, of states of existence. So this is, of course, a much, much more difficult question in terms of the interface with science, and especially when it comes to interface with biological process. I don't think we put this part as an explanation for how the mechanisms could occur, while it's very clear how it can happen in our experience, and everyone could understand the effect of afflictive emotions on the short and the long term in our happiness and suffering. So
specifically here, I should say that if steroids, corticosteroids, are immune suppressants. Corticosteroids are released in response to emotional situations, and they are suppressants of the immune system. They seem to work at many levels. We have not worked out all the details of how corticosteroids suppress the immune system, but there's a linkage between suffering, corticosteroid release, and biology like this. It's clear. We don't know what the steps are, but there's certainly the mechanism is in place.
And in that sense, I think an explanation in terms of karma is compatible with this kind of understanding of biology, and Your Holiness was pointing to that in terms of our actions producing either wholesome or afflictive emotions, which will then initiate a cascade of biochemical changes which can impact the kind of molecular machinery that Ben was referring to.
So that's clear enough when there's a consciousness involved for now. But I think we have to be humble enough to acknowledge there's an explanatory gap when it comes to the influence of karma of past life on biological processes. So there's still a mystery and honest.
There's a lot of mystery.
But I think we have to be clear that we don't have to propose a clear mechanism of intervention. No. And as Jonas said, if there's nothing, we cannot find any other cause, there's room for that. But I don't think we have the...
And actually, the very modern views of this, actually Moshe Seif, who Mathieu knows, who's a molecular biologist at McGill, who works on the mechanisms of alterations in gene expression, yes. Some of his recent work indicates that actually the methylation status can be transferred genetically.
That means the influence of state of mind, affection of the mother, yes. All that as a epigenetic effect, it affects the expression of genes, and that can cross generations.
And to bring that to this talk, the structure of the gene would determine which of those modules is picked up. So if you changed methylation pattern, you could change which of the modules is used. So clearly, there are possibilities.
You want to explain methylation?
Methylation.
Oh, no, I don't want to explain that. It's a change in gene structure.
Okay.
Just say a change in gene structure.
And it's a way for experience to actually change the extent to which a gene is expressed or not expressed.
And structure changes and its expression changes.
And you might remember Michael Meany's, where the mother rats are very caring, then the baby stress rat, the gene is which expressed for stress is blocked through methylation, so it has an effect on the expression of the gene. That's what it means.
And since karma is so closely associated with one of the main expressions of karma is just our emotional habits, that the kinds of emotional habits we have are a major expression of karma. So thinking about karma in terms of those types of emotional habit patterns and the effect they have on the immune system and methylation patterns and so on does make a lot of sense.
Yeah, so
but that's a sort of gross level. It's not really going down to that minimal causal level, but still, it makes sense.
But I think that the overall analysis that we've just been describing suggests that there are ways to accommodate the influence of karma, not just in this lifetime, but across generations.
Yes.
And I think that that's very exciting.
If I may add just one thing, one of the main factors that's supposed to be carried away by the stream of consciousness are those tendencies, like tendencies to affection, tendency to anger and so forth.
Right.
So there you could see a possibility of this epigenetic, because we know that the stressful mothers epigenetically can transmit the stressful behavior.
Yeah.
So in some way, I mean, there's a little more, not completely closing, but bringing something towards the direction of closing the.
Sure, there's a biologic system that makes sense in terms of something else being imposed upon it, like karma.
Now, to expand it even further, Arthur would like to suggest how the earlier discussion of quantum mechanics may actually connect to this. So I turn this to Arthur.
Thank you.
내가 제일 찍은 인더스트리.
Yes.
안다 되게 안 되다기. 심 기류
Nare.
왕기 다 immune system 들이 두고 되게 사우샤로.
Nare.
디 레리스로 아니.
No. Leg.
leg 있어 그냥.
Yes.
미 시가
근데 다음에도 버시로기 ene tangzil na de lamar ba.
Nare. Yes.
That
So even in the case of
그런 어디 말이란다. 심 기울고 왕기. 봐. 배나 파마 심 기울여 있나? 나 저도 아마 심 기울여 있나? 디마 가져다. 차 나로래. 아니 그때 진지는 야가요야지.
보고게 박차대.
자, 삼로든 저 얘기를 차. 다른 건 아주 샤샤니 심 기울여 있나? immune system 이 야가요야지. 아니 심 쉬우지 부스도 제지 쉬우지 뭐 기우시 여러 있나? immune system 이 쉬우지 거 봐. 딜랜드에 서래. 딜랜드 아니나.
랜드 차시죠.
얘네 미 시가 페나 미 시가
박차래.
라
디고 그게 팬은 저기요. 팬은 저기요. 딜랜드 팬은 있나면.
Nandelle gumero.
페나 가 다바르시 셈부서 토베나
가.
가 다바르시 셈부서 토베나 띵게 시가래. 네 시가 데 렌제 게 캐치 마르베.
젤. 그 박차대 즉바사야 그 박차요나 딜 레저.
Tunge slapsa to lele gumero.
tawa mi control sayaina churunne so lese borwa tadi koran
His Holiness is wondering whether in this causal processes we are talking about, say, imagine a person whose unhappy and stressful states of mind has an impact upon the immune system and at the biological level and has health kind of consequences. Whether that causal relation could be called karmic. His Holiness is questioning whether that could be just a purely biological.
Whether that would be a karmic event or not.
And we were.
Can Your Holiness explain why?
No, His Holiness is thinking aloud, but there seems to be disagreement here. On this side, we seem to be saying yes, it is karmic effect.
Effect from mental situation. That I don't know. In the category of karmic link or not.
So I was asking if the immediate effect of stress upon and immunity, is that effect karmic or not?
Yes.
And what I was pointing out is the fact to be stressed seems to be a result of karma. This is a tendency.
Yeah.
But the
immediate
mechanisms
effect.
to go from being stressed to affecting immunity, whether that is as karmic mechanism or not, that was his question.
But Shebana Chashanada. Shebana Chashana, but Niji Kombaina, Shana Chundu Warba. The karmic remare. The Gamamarvada.
For example, to give an example, if someone cultivates compassion and enhances compassion, then that person's kind of propensity towards hatred decreases.
And also fear.
Decreases. So
His
His Holiness would say
that's
that
not karma.
His Holiness wouldn't say that's a karmic effect. There's a simple cause and effect.
있나요?
그니까
얘네 밀롱 사보 얘네.
네, she당 마 차산에 대 제마다 레상보 용으로.
네, 가면 되버지들
네,
레요.
그 차시래.
세상 레저다. 근데 닝시 개베이나 라 상부시 내용 그러다. 디라 상부
지 마음바야.
디 그도 그러다디.
마음바 니지 박사 용 거래.
네. 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 제로. 답은 너무 들었을라나? 너무 들었을라니 마음을 알아 봐.
나린
제가 교통이 되고 마음을 알아 봐.
다시 균제기 제버샵에 그 차시지 레기 제보다 딱 차시 그지 차시 정말 레기 인구
답은 수구 안도 수구 요원도다. 답은 수구 아니는데 저기 멍구지 거기
중이랑
봐. 거기 제가 누구를 전에 혼자 찍도 와.
그 개구가요
가.
근데 균제기 림버 진나래
그래.
그 뭐여차네 차 디간
다들 여기 숙긴 돼야지.
맞아. 마음바 따라오는데 고수도와.
가.
대신 니제 숙체나.
네.
다 계속 제마야 니제 박사 때 시작으로.
네, 제로.
다 마음바 때 고수사로. 레사야 고수사리. 박사고 규든 고수사로.
네, 권배왕.
딘상다 레데데 니랑 도그라 박사 사산.
가. 교륜저에. 제가 당연히 류일에 마십시오. 류가래 유샤. 그래서 때 일에 가는 상담이네.
고수사로. 그 맞존나더니 딱 가지고 고수.
다만 다디 뒤균제 안데 다들 인지 공부 저저 인지 숙성봉도 교하다. 시장 숙성봉도 교하다. 대 장제 여러다. 대 다주 주시. 단 인지 숙성봉 개베 아니 류기 중어디디 찬유버차. 콩주수 잡고 개베 낀기 류기 중어 많이 버차디 딜랜데 더 도듬도.
레기면 가서나디 닝지 겐기 선 가서 대화께서나 대화대 레기면 부샤고
등은 사실은 레기면 그러면 다들 인지가 못 되는 말 봐.
람 배야 대구가 아유
다다 모두는 이제 사그라 발라.
가.
근데 레저저저 되어라.
네, 내 소심을. 가. 오늘 도중육래.
던지래.
아시잖아지
다들 선 접으면 제가
이니 미쳐
겐디 슈거 근데 bana 닝지 게베 때는 다 immune system 교수 주고
그래
그라 델리아 레기 저에 차지샤 그냥 그라 레다 더 매대 춘이기 교원 준쟁으로 단지
어디 야고도 왜 야고 전에 야고도
이샤 정말
어디 야고도
가서 그
네 야고도 그 야고 썼어 말해
I'm just wondering because there seem to be two contrasting positions here, but I was saying that
two possibilities.
It's a way of, for example, you can see a causal, and this is not translating, of course. You can see a causal event, say, as a result of experiencing compassion. It has an effect on the immune system, which then leads to health benefits and so on. So there is that causal mechanism. So I was saying that we could imagine two aspects to the causal processes. One part could be just pure natural causal processes, but there could be an element of that which could be seen as karmic, because the individual gets a benefit, and that benefit, a wholesome benefit, is an effect of karma.
Yeah.
So we can see a single causal processes having two different. So he's only saying this is a cop out.
This is a what? Cop out.
A cop out.
Cop out.
Yes, no,
It's both yes and no.
Yeah, we just went standby.
그래서 하여튼 80이니까
디시 하나만 더 신데
80면 80이요.
진짜 쓰고 싶지 그러나.
그 춘이공 용대 망구지가 되지.
Is it getting better?
간다 이모션 되게 레벨 텐데요. 레버다 직수부 그 이뮤 시스템 더 랑싱 요와. 유디고 단인지 제베기 이모션 디 레벨 교대 레벨 교대 이뮤 교대 이뮤 교대 대화진 용서나 다한테 레 데레 그러고.
They seem to be out of power.
It's not getting power.
미 레벨이 춘주 레벨 숙세요.
It's not getting power.
Here's the thing.
It's not charging.
자사가 미
The charge
레벨
is not on.
세트이요한테 레벨 좀 말해.
그래서 렉 차지 랭 그래.
됐지.
레벨 참여하면 돼.
다 에볼루션 코랑 돈 줘야 될.
아,
Teta gyundun ke tesi gyurja na koso pentu komarwe.
라
Gyundun ke lechi yorwala.
규정은 제부세.
Ninje ke na yon ninje paksha shukcha di koso gyurja na penkri samadu.
그냥 쏘나 쏘나잖아.
So one of the I
It's
think was
unplugged.
that was discussed. It's okay to say.
Keep talking because we don't have
Yes.
anything else to
One
talk
of the
about.
there are two
Yes. Translation, yes.
So, okay, there were two types of causality envisaged. One was the natural law of causality, which is maybe that if there is a compassion thought, it will immediately reflect on the immune system.
Here.
So from that perspective, the mechanism of influencing down the immune system is just normal causality, maybe no karma involved. But as you generate compassion, and then moment after moment, you are definitely establishing a state of mind that is antagonizing hatred or the idea of harming. And therefore, moment by moment, you are building up a karmic tendency to be more compassionate. And one of the three effects of an action or karma, one is the sort of a reproducing effect, that there will be an experience that is similar to the cause that has generated the karma. That means the more compassion you grow, the more you have chance to have experience a compassionate being in this life and in future life. If you cultivate hatred, you have more chance to experience hatred, also be a hateful person in future. That's one of the aspects of karma. So in that sense, by accumulating compassion, you do build up, you are the architect of your future being a compassionate being, but the immediate effect on the immune system might be just a pure law of nature, which doesn't have to be karma. So there's two aspects involved.
그래서 제가 나한테 요리 통과하지. 미류디 개저 말해. 미류디
맞아요.
개저 봐.
No.
다 미류나 개치질 봐 말해. 이 개저 위기로.
나 이슬람으로
가.
나래.
자자다 미레바디 개저 위기 전에 레바스르도 도도로 직 수도 샤 말보다 제가 샤장로다 튀고로 봐. 자 디디 랭저 말해다.
샤고
그래서 샤 스마트 용대한테 레이트 좀 줘.
이슬람으로 됐든 내가 안도
다운디 제를 레저 말해.
말 진도 없네 이나
제 그거들은 용대한테
나래.
레 말해.
제가 교대 이용할 때 이슬람 쪽 라고 봐요. 뭐 진도 없는 레이네. 그난 그게
아주 디테일이 다 디멘더스.
라고 봐요.
그러나 낙제 요때부터 어떤 당제 그 레이왕용. 이 타제.
나래.
다 이제 단 낙제난기 지다 가서 우리 신담면다 지금 로만담면다 디디게 코르코르 케미컬 소소소다데 가시에는 가서 차와여사 처우여다 가시에 정우여사 처우여다 가시에 사자 감보 처우여다 가시에 가서 샬련이 처우여다 디디 코르 릭직디 케미컬 코르타는 배진 거면 또 주니기로 다 다 이제 두두지
나래.
자와서도 두두서 디타는 돼 그래. 그 주님 말해.
그 중이라 하래.
그래.
되게 말해. 그것도 되게 그
그래.
말
어디 등질 내내 차되게 대화자기가.
말다.
그 저단계 보네.
레든 대화 메시가 말다. 레든 대화 얘기들이야. 양 코로나 낭슬이야. 레든 대화 얘기 차지야 줘로 왔어. 근데
담에도 싫어 그 등진이 뇌니 등진 슈슈르 심배서기 미디네 다 소자디 심기로라 연구를 봐. 디 담에도 싫어 되 되고자 서와요. 나 레게 어사주시다지. 근데 디게인디 담에도 싫어 드셔야지.
So it's interesting. His Holiness is saying that from the Buddhist point of view, and this is of course from within the Buddhist world
다
view.
디나데 가서 부두 스캡 건지.
So we're wearing the Buddhist hat, of course. So within the Buddhist world, we would say that human existence is a consequence of good karma. So, and in that case, what is most precious of human bodily physical existence is the brain, which means we have to also say the human brain is the consequence of good karma. Now, then the question arises, if we go to this level of description you are giving, all this, genetic level, chemistry level, would we say all the mechanisms that's going on there, is that also part, a function of karma? Perhaps we would say no. And the example would be, from the karmic theory point of view, the environment where you live is also a part of the results of your karma. So imagine you're living in an environment where there is a beautiful forest. But within that forest, there could be so many detailed aspects of that forest, different kinds of trees, that they respond to the natural environment, the thread, and all these kind of fruits that they will give. This will have nothing to do with the karma. There might be a natural... Evolutionary and
of course, in evolution also, I think in some cases, a karmic link may be there. But some evolution may be purely chemical or natural
processes. So
complicated.
Yeah.
I agree.
More discussion, confused. So
the problem is the more we discuss, the greater the confusion becomes.
So, should we move on then?
Please.
Okay.
Ka. Really? Did he? Oh. So. Then Sajate Mizanji, Namu Mizanti, Yevakaduria, Jig Session, the Shingle of the Yausha. That Mizanti, Midi, Miss Savage Lake design, any Namu Lambusa Yawu Yudevati, that Lambuchun is yon to that did Landeke Shore.
The general discussion is about how much karma influences the workings of the environment. If you plant something, someone else comes along and plants something, one person gets a good harvest, someone else gets a bad harvest. Is that a result of karma?
Okay, where do we stand now?
There are contrasting positions here. Yeah. That's the...
Move on.
Should we move on?
It's good to see that scientists are not the only ones who have these kind of disagreements.
So I wanted to then get to the second reservation about competition for reproductive success and the inability of Darwinism to explain altruism. This was a key point, and it's going to be the focus of everything we do for the rest of the day. Darwin actually saw the difficulties of this issue, and he said that this was a special difficulty which at first appeared to be insurmountable and actually fatal to the whole theory, because he thought he couldn't explain altruism with this type of position. And then he looked at beehives and the fact that bees were collaborating in environments like that, and he thought, well, maybe there is something, at least at the level of a familial relationship, where people might cooperate because they're part of the same group. And this is now spoken of as kin altruism, but we know that cooperation in humans and animals, some animals, extends far beyond kin. It goes on, and so yeah. So cooperative acts exist often, even with a cost to the individual, and even when you look at the most reductionist biologic perspective, cooperation is necessary. If you take the most materialistic position, and I will say, for example, the idea of a selfish gene. The selfish gene idea is that a gene will try to, genes don't try anything and they don't think about anything, they're code. But it would be advantageous to a gene to be passed on to the next generation. That's basically what a gene... So the idea of a selfish gene would be a gene that has its structure best to be passed on to the next generation. And even if you think so materialistically, you're forced to think about cooperation. because no gene exists in isolation. Every gene interacts with thousands of other genes to make a cell and an organism. A gene must be cooperative to be passed on. Any gene that goes off by itself to cause a cell to divide becomes a tumor and kills the organism. So it's necessary that genes, selfish genes, have to be extremely cooperative. They've got to make cooperative cells, cooperative tissues, cooperative organisms, cooperative societies to be passed on. So even at this materialistic level, you see that cooperation is essential. And in fact, there's some examples when genes don't cooperate, and it's deleterious to the species, and it moves this. So this is a very, even materialistically, cooperation, obviously. A brain gene that wants to get transmitted has got to make it very healthy, has got to work to be a healthy, functional organism. So in this sense, as biologists have thought about why altruistic genes persist, there have been a number of theories. Some of these are kind of evolutionary, some are economic, involving advantage to the individual. Some of these will be discussed by Richie at more length, but I just want to introduce them in this setting. One is this idea of kin altruism, of helping someone who's related to you, because if you help your brother shares about half of your genes. So his children will pass on, your genes will be passed on to his children, and consequently there may be motivation to help a relative because of shared genes. This could be expanded to larger populations. You may decide that one could help someone else in the room because that person might help me. In fact, I might identify that person as the kind of person that's a helping person. Maybe he's a Buddhist scholar and he's an altruistic person. So I might be more tempted to help people like that who have proven that they're altruistic because it's likely that they would help me. The kind of reciprocity. You identify in someone else or a population the possibility that there would be reciprocity and maybe that they would help you if you were in difficulty. Or genes may be passed on because they make a person likely. Suppose I live in a village and the neighboring village is causing me problems. One plan A might be to go over and kill as many people in that village as possible. But plan B might be to go and try to resolve things and put in place structures and laws that allow both villages to survive. And clearly, I wouldn't be killed in such a battle, and thus genes from this conflict resolution might be passed on. I'm not doing tremendous justice to these, but I'm trying to give a picture of the kinds of things that occur in biologic models, and Richie will talk about more of this. Or it might be that people who are altruistic look better to partners, and they may have a better ability to get partners and to pass on their genes that way. So these are the environment in which many of these hypotheses are placed. But I present these to say that I am not convinced that these are extremely robust examples of ways to explain the most difficult aspect.
Evolutionary biology don't disijab na kanga tengorba. Disijab tandelia. Rikashes lectus kashes na. That's just Suzu and Revo Debedina. The Pension Pass Rogojem and Suzu.
So I'm giving a personal opinion.
Parogojem and Surogach is reciprocity. The Surogochi that Cherum and Michele Parogochis.
So this is a personal opinion. I'm not an evolutionary biologist, and I understand these ideas, and I think they are important. But they're not convincing to me about what I would say is extreme altruism. Real, and this is, by this altruism I mean actions that are intended to benefit another person, even when the risks are great to the individual. Tremendous risk to the individual. And this was actually expanded upon in a book that I read and I gave to Paul, and he's going to speak more about this later, The Heart of Altruism, by a political scientist named Kristen Monroe. And she examined people who were extreme altruists, people who, for example, were real personal heroes. There's a man who was hiking in the forest, in the mountains, and met a woman who was crying because her daughter had been taken by a mountain lion. And he picks up his stick and some rocks, chases down the path, beats on the mountain, sees the mountain lion with the child, beats on the mountain lion, throws rocks at it. The mountain lion drops the child, attacks him. He continues to beat it. The mountain lion finally goes away, and he saves the child. This kind of immediate reaction, putting his life on the line, and people do behaviors like that. So this is one category. Another category that she examined these people by giving them questionnaires and trying to see, how did these differ from other people? What do you see in people who do things like that? The other group of extreme altruists are even more so. These are people who protected Jews in Germany from the Nazis. So they didn't have a single act. They did something for weeks or months or years, and they would shelter Jews in their homes at a risk to themselves and their gene pool, their children, their entire family. Now, these people are really different than a lot of other people. I mean, they're clearly different. And she tried to find out what characteristics exist in these people that make them different. And there's clearly not socioeconomic differences. She looked at that. There are no real religious differences. In both groups, there were religious people, just as in the normal population. And she contrasted these people to a group of philanthropists who were good people who had never been put in this situation, just to see what good, normal people are like. Same socioeconomic. Religion. These were not particularly religious people. Some of these extreme altruists were, in fact, atheists. So just like everyone else, the whole spectrum existed. There was no category that you could tease out to explain from a social, political, scientific point of view what was different. The only thing she found upon questioning and pushing these people was that they just looked, they had a perspective. They looked at people in a special way. And the way they looked at people, they really believed, and as part of their being, as part of their flesh, that all mankind is connected, that every individual is linked to every other individual and is entitled to humane treatment just because they're alive. Just that reason, a deeply felt, simple recognition of the fact that we are all human. And they felt that as part of their existence. To me, as a tiny Buddhist, it looks to me like this is great compassion. This is an example of great compassion. These people, or bodhisattva-like behavior, remarkable. And these are not Buddhists. These are not. Many of these people aren't religious. This is just the way they are. It's a remarkable thing. And when you think about people like that, you're forced to wonder about yourself. How would you be in a situation like that? You know that these people are ideal people for modern psychologists to think about and to try to explore about great compassion, because these people have exhibited great compassion. And the story that one gets from here, this is reminiscent of a poem by a great British poet named John Donne. Not this one, but John Donne that existed 400 years before our John, in which he said...
He's reincarnation.
Yeah. He's the reincarnation of that one, right?
So same name, no?
Yeah. No. So John Donne said, "No man is an island entirely of itself. Any man's death diminishes me because I am involved in mankind. And therefore never send to know for whom the bell tolls. It tolls for thee. Every death is my death." That feeling, that great compassion, is what we strive for. We would like to train for that. But that's a very unusual characteristic. So I'm glad to... So I agree with you that Darwinian evolution today doesn't explain, to me, altruism at this level. I don't think these evolutionary models can explain that. And maybe Richie will disagree, and we'll see, because this is a personal opinion. I believe that what you said here is true, that until there's a credible understanding of the nature and origin of consciousness, the scientific story about this is going to remain incomplete. I wanted to ask you about your thoughts on altruism, but I think that will be better after we hear from Richie and maybe even after Paul, to understand I mean, just what are your thoughts about why, in a population of people who are not trained in any spiritual practice particularly, or certainly in great compassion, why do some people instinctively go out at great personal risk to do such incredible acts of compassion for others? I wonder
maybe we can begin after the tea break.
With that, if you could maybe talk about that after the tea break, because to me it's an enormous challenge for us to understand. So thank you very much. These are the points I wanted to make.
Thank you. So, tea break for 15 minutes.
내가 콘기 남주디디 야 라베간 레기스 말에 콘tum 그 남주도 라베간 레 말에 tana kuran 츠버레샤 츠버레샤
바이올로지로 있나?
라베간 레서
말 바이올로지 라베간 시.
잡아서
콘덤서지 베.
콘덤 바이올로지 타고 있네 콘텀 레벨 간 바이올로지 매바
Arthur was talking about the fact that you could explain an influence on mutation by looking at the quantum level of the chemical reactions that are involved in mutation.
Yeah, but
So he's going to start with that question? Is that the
I
plan?
think we'll get to it at the end. So.
The way you would explain mutation is the way you
So,
explain
Your Holiness, I'd like to now continue with the discussion that Ben ended on, and I'd like to just make a short presentation on evolution and altruism, and then end with additional questions of the sort that Ben described, where we'd like to ask Your Holiness to comment on the Buddhist perspective on altruism and compassion. So I want to just first review the problem where you said in your book the current biological model does not allow for the possibility of real altruism. And this second quote is one that Ben also showed regarding the drawbacks of Darwinian evolutionary theory. And what I'd like to propose are two solutions to this problem. So first, let me just remind us of what the standard model is. The standard model says that altruists behave in ways that decrease their own fitness while increasing the fitness of others in the population. So because of the way they behave toward others, they help others' survival, but at a cost to themselves. Whereas selfish people do not incur this self-sacrificial cost, but they reap the benefits from other altruists, and thus they have an adaptive advantage. That is the standard model of why altruism may be a problem for evolutionary theory, and I think it was this kind of idea that motivated your criticism of, or your comment on the limitations of evolutionary theory regarding the problem of altruism. So I'd like now to propose two possible solutions to this to show how they... In this regard, I can't resist telling you about a very interesting study regarding altruism and selfish tendencies in different academic disciplines. And this was a very famous study done by an economist that you met, Your Holiness, at a meeting here in Dharamsala that I organized, I think it was in 1995, Robert Frank from Cornell University. And it was a study that he did. And what he did is he examined freshmen in college, college students in their first year. And he measured by asking them the extent to which they are willing to cooperate or to behave selfishly in a variety of situations. And he found a group of people who he matched on their level of altruistic versus selfish tendencies. And then he followed them over the course of college. And one of those groups majored in economics. And another one of those...
economics.
간자로.
말에 단디 네 라브라 당부 중에 로 당부들이야 그 대전직 루 다들이야 구주 저망 버티제 네 란진준 숙치주 란도 숙치부 간이 임제당 그다 문진제 네네 라브라 튼두가리아 네 구주 대전 그게 남도도 대전 그게 남도도 때베나 대전직디 네 economics 벤존 옵션 제일스.
So one group majored in economics, the other group majored in astronomy.
Astronomy.
Astronomy, I see.
It's two examples. Picked a science. He picked a science as an example. When they were freshmen, they were identical in their selfish versus altruistic tendencies. Identical, matched.
개발이들.
개발매대봐.
충분.
충분해. 다 찬양법. 찬양법.
After 4 years of college, the individuals who majored in economics became significantly more selfish.
I see.
Big change over 4 years. And I think it is a testament to economics in the West. So let me now focus on two possible solutions to the problem. One is what we call group selection. And it is the case that group selection as a theory in evolutionary theory fell out of favor in the 1960s. But now it is making a very strong comeback, and many of the most well-known evolutionary biologists in the world are writing about group selection and have commented favorably upon it as a theory, particularly in relation to altruism. And Darwin himself appreciated the importance of group selection, and I'll show you that in a really interesting quote. This comes from The Descent of Man, written by Darwin in 1871, and I'll read this quote. Darwin said that there can be no doubt that a tribe, including many members, who from possessing in a high degree the spirit of patriotism, fidelity, obedience, courage, and sympathy, were always ready to aid one another and to sacrifice themselves for the common good. And these would be victorious over most other tribes. And this would be natural selection. At all times throughout the world, tribes have supplanted other tribes. And as morality and the number of well-endowed men will thus everywhere tend to rise and increase.
So
the idea that Darwin is acknowledging here is the possibility of selection at a group level.
That evolution, the selection, natural selection, the make a species kind of subject group.
And in this case, the group is the tribe. So there are mathematical models that have been developed that very rigorously demonstrate that if you make one important assumption, and that is if altruists and non-altruists can segregate into groups based upon this characteristic, where more altruists tend to congregate together and individuals who are more egoistic tend to congregate together, that altruism can evolve according to the fundamental principles of evolutionary theory. So there are rigorous mathematical proofs that this kind of group selection can occur.
So Holiness was saying that this is more like a kind of a group identity, a sense of belonging to the group, rather than altruism as such.
Of course, altruism,
so altruism comes in, some part of it.
Well, it is a kind of, I think it's very much more of a limited understanding of altruism compared to the Buddhist understanding. It would be behaving altruistic toward members of one's group.
Yes, right.
So, but we can define the group in different ways. It can be a narrow definition, but it can also be a more expansive definition. And so the basic idea here is that although altruists may incur a cost to themselves because of their altruism, they benefit the group, and the benefit to the group outweighs the cost to the individual. That's the basic idea. And the next slide has an actual mathematical model, and I'm probably going to skip that in the interests of time, but this is just one of many models of this sort that actually show how you can get an increased number of altruists in the total population if altruists and non-altruists segregate into different groups. But there is another solution to this problem which has been talked about less in the scientific literature, but I'd like to advance, and it's actually a solution that Your Holiness, I think, has very much anticipated, particularly in your comments that you made during Ben's discussion. And that's the following, that altruism and compassion engage brain circuits of wholesome emotions, and that these can have beneficial effects on our health, which promote survival. And there are now beginning to be scientific data which support this general hypothesis. And I wanted to just show you one example from our own work, where if you divide people on the basis of measures of brain function that are associated with positive emotions versus more destructive negative emotions, there are big differences in the kind of indices that Ben was talking about, big differences in immune function. And this was a study that a graduate student of mine, Melissa Rosenkrantz, did a few years ago. And I'll just show you one slide from this. And so the blue bar are a group of people who are defined on the basis of brain activity that is associated with positive emotions. And what we're measuring here is the immune response to a flu vaccine. So we actually give people a flu vaccine of the kind that you would get in a doctor, and we measure the antibody titers that are mounted in response to the vaccine. And that gives us a measure of how effective the vaccine actually is working. And what we can see here is that among the people who have the profile of brain activity that is more associated with positive emotion, there's more than a threefold difference in their response to the influenza vaccine compared to this group. And so it suggests that there are very large differences in certain aspects of immune function in individuals who may be cultivating more wholesome emotions. And this may confer an advantage. And there are many other examples of this sort, not just in the immune system, but in the cardiovascular system and in the endocrine system that also are generally consistent with this idea. Now,
그래서 낮에 그렇게 교사래.
나래 근데 나도 소해 말해 단디 몽고 갑자기 잡는 다들이야 디날 내게 제대로 봐. 다들이야 돈을 주고 내지보리스 노.
Now,
Yes. I mean, there was a study which really struck me about 10,000 people who had got heart surgery and seeing the rate of survival after 1 year and associated with anger, the trait of anger. And there was a huge difference of much less survival among those who display a strong traits of anger rather than those who didn't display that trait.
Paul?
인정 주시고.
I don't doubt your finding, and I like your finding. But I wonder if this has been the case over the course of thousands and thousands of years, then why aren't we a population in which altruists predominate?
그래 노동자는
나래 단디
아주
지난해부터 스테네 간다 대배도 중에 돈을 너무 부시부지 뜻이면은 그때 되는 거네나 다주 아주 미치도 나려야 신배진의 망부 매부터 가이나스.
Did I environment is 말해?
Maybe a result of the environment,
Or condition.
conditioning. Yeah.
I think those. I think even United States, or those industrialized nations, I think the people's attitude regarding sharing others' problems, right?
Yeah.
I think among the villagers
Rural areas.
or rural area, maybe I think sense of cooperation, sense of sort of community, I think stronger.
See, I live in the Midwest. People are cooperate and are very
Not San Francisco.
I resent that.
You'll be in Madison soon, Your Holiness, and I know you've been there many times before, but it took me a long time being a New Yorker to appreciate the fact that people are genuinely cooperative and nice there.
First, however, which were prepared.
Now, I want to just spend a few moments on a body of psychological research, and actually Mathieu suggested that I present this very briefly because this work has been influential in the psychological understanding of altruism. And this is work done by a social psychologist by the name of Daniel Batson. And the basic question which he was interested in is whether there are egoistic explanations for altruism or whether we can rule them out. And by egoistic explanations, he meant the following kind of situations.
간다 그래 간다 배트맨 그 사이콜로지스트 또 그런 게 다시 제가 갈 샴페인치 얘기 미기다 군론다 차와들이야 랑들 돈에 대시제요네 매나스.
Two egoistic explanations are these. One he calls the empathic joy hypothesis. And this hypothesis says that people behave altruistically because they want to gain the good feelings that derive from sharing in the needy person's relief.
그래 민수.
나래
민사를
말해 매일 파 로봇체베나 로봇체베가야 파나무 동에 로봇체도 걸 수수 기부 준 거라. 수수도 이츠버 줘. 이츠버 된돈이네. 아니 신 로봇체베서 그렇지.
데이비드 솔바.
네. 이 문제는 이츠버 된돈이 말로 당한다. 이내다 이츠버 주고 요한자 디 된돈이 굴롱 것도는 신 로봇체가 요래서지. 되시 단체체.
So they're not really behaving altruistically for true altruistic motives, but rather because they themselves want to experience empathic joy. A second egoistic explanation is called the distress relief hypothesis that says that people help to relieve the distress that arises from seeing another person in need. And so they want to relieve their own distress.
시엔동가 나와 통보이나 인데 미세버 수술 마치 비고여서 마치부터 세야 된다려. 제베서를 다가나 랑 김전진.
And Batson has done a whole series of experiments. And I'll give you one example from his experiments. In one experiment, he reasoned that, that good news about a needy person's improved situation, so if a person in need experiences an improvement, that the good news about that would increase empathic joy. And people should be more inclined to help if they believed that a needy person's situation was actually improved. That would support this alternative egoistic hypothesis.
Can you explain that? I didn't get it clearly.
Yeah. So,
how does the reason proceed? So,
pardon?
how does the reason proceed?
Reasoning.
How does the reasoning proceed?
So the reasoning proceeds. Let me actually describe the actual study. I think it'll help. Participants were told that a needy person was either 20%, 50%, or 80% likely to improve if they helped that person. And if the empathic joy hypothesis was correct, then the amount of altruistic behavior that people displayed should vary as a function of whether it's 20% likely that the person would improve, 50% likely, or 80% likely.
And panangol robot get pen panangol pen to get in shutamba, getting up to them, get Jerutambas. This is yours labina. The chisam give panangol robot in pen to church mangayune, these robots into Shukcho young or was.
The results show it makes no difference.
I see.
No difference whatsoever. And so he was able to rule out this egoistic hypothesis. And he's done many other studies where he shows that egoistic accounts cannot account for the empirical evidence. And he concludes from this that genuine altruism exists.
No.
That's the bottom line. However, these experiments have been criticized by both psychologists and philosophers as ultimately being unsatisfying. Because if we allow the egoistic explanations to appeal to internal rewards, to subjective experiences of happiness that we might have, that a person acts altruistically because it increases their positive emotion and not because they're genuinely motivated to help others. And so this has been a criticism that has been leveled by both psychologists and philosophers at this work. And this is an area where I believe the Buddhist account has a lot to offer.
So what was the criticism? I mean, what was the point of that?
Maybe could you explain why it's different from empathic joy? Because it just sounds the same as empathic joy.
The empathic joy is slightly different because there are an explicit differences in the likelihood that a needy person being helped would relieve that individual's suffering. So that's what the subjects in the experiment were told. So there wasn't direct reference to the internal subjective experience.
Because it was tied to how,
exactly,
whether there was a benefit.
Exactly. So the question that I want to now end with is this. If behaving altruistically and with compassion increases wholesome positive emotions in the individual who is exhibiting altruism, does this in any way call into question the motive or intent of the person? How can we best respond to the critics who argue that we only express these virtuous qualities for the selfish reason of making us feel good. And so this is an area where, from my very limited understanding, it would seem that the Buddhist perspective has a tremendous amount to contribute. And so finally, it would be wonderful if Your Holiness can discuss the various types and stages of altruism and compassion from a Buddhist perspective, and how might sympathy and empathy and compassion relate to one another, and what is the relation between compassion and other virtuous qualities. So I ask you, please, Your Holiness, to help us with these issues. Please.
This fits right in with your questions. I remember 7 years ago in this room when you said, when you are compassionate, it helps you more than the other person.
Yes.
And just the other day you said to me, when you have forgiveness, it primarily helps you. So I think that fits exactly.
Perfectly.
How do we understand that? I'm not questioning that. I'm trying to understand then, is this criticism that if it's good for you, it's bad? Should we care about that at all? Isn't that an irrelevancy?
Yeah. If it's good for you, it's not real altruism.
Right.
Yeah.
So
라레 말하는데 요로도 연구 살았다는데 제가 같은 놈쇼고 그런 줄 니지 뭐 샤당 것도 강한 책으로 봐. 그저 셴벤스라 되고 수술이에 편도사는 해야지. 배트 셴벤다 랑페만 이브데 다시도 뭐별 안 찍어로. 근데 그 전에 삼단 되고 딱 kuzu지 시행을 펜베 자와데 제주가라 아니 수술을 딱지 셈기보다 안데 용거로 와. 딱지 용거 그런 군들 대가나서 아니 시행이야 제 답받침 받아. 배트지 되고 딱 미주 아니 디 아니 셴벤 뭐만 말했어. 그래서 나 랑라 펜베 아니 랑도 그 군나랑 버레스. 그래서 티 데부 랑 펜겨로 와스. 랑도 주 군나랑 버레스. 딱한다 디데부 랑 팽겨나 인지미지 셴벤데 랑도 죽고나랑 고요나 그래서 그거예요. 말 팽기 두 삼제니 셴 로고체부터 기마로.
자티 그래 무시하다 altruism said sikora 다르보 뭔가 사용 걸어 봐. I think altruism there could be I think various levels. And as well as compassion. Some limited altruism or compassion as a social animal, I think biologically also is some because of that.
Possible.
Especially, I always feel like that. The mothers sort of very because of that, very I think, genuine sense of concern about their own child. And child side also, tremendous sort of feeling, closeness, the feeling of totally relying on the mother. That I think, at that time, the child do not know who is that person, isn't it? And no idea about altruism, these things, but simply biologically, your survival need others' care, mother's care. So biologically responsible, right? I think it's the extent that. Some extent, I think the society or community, the feeling of community, sense of community there. So other suffer, so you cannot bear, right? You want to help, to share. But then in such case, the so-called other community, enemy community, I don't think it's that kind of feeling. So that's, I think, primitive altruism or compassion. Mainly, I think, biological sort of response. But that's the seed of compassion or altruism. Now training, reasoning, the beneficial
value of
compassion. Now here, I think, if I practice compassion or altruism, I also get maximum benefit. Okay. Some benefit out of harming other, it's very bad. but benefit out of help other. It's excellent.
Sure, no problem.
Marvelous.
Win-win.
No problem.
Win-win.
That's right. Oh, that's right. So, digduwa.
So what's the problem?
No problem, I agree. That's absolutely right.
So I think at the level of training, of course, all these are the altruism give us benefit, not only other, but also me. And now, not only peace of mind, but also good health. So now these are the reason changes.
So when you employ
Training.
in your training for compassion, you can reason, and as part of that reason, you can also cultivate the awareness of the beneficial effects of cultivating compassion, and these may include one's own benefits as well.
And from the Buddhist viewpoint, of course, important is compassion or sense of closeness, sense of concern. I think the more natural sort of physical stuff, on that.
Biological.
Biologically.
I want to say something.
So from the Buddhist point of view, those elements of compassion or sense of care, concern that arises primarily because of our biological constitution, from the Buddhist point of view, there will be much stronger involvement of attachment as well.
So therefore, essentially, that is biased. That same feelings, you cannot reach towards your enemy. Now the compassion or sense of concern through training, then even your enemy, then that kind of attitude can go. So that's unbiased. Now in that field, now entire sentient being, not only human being, but all other sentient, and particularly among the human being, particularly your enemy. So that is the basis of forgiveness. Isn't it? Even Christianity also is the same. I think here is useful. The God, same God, is to create our enemy and ourselves. Essentially brothers, sisters. Isn't it? If we too much criticize about our enemy, then that indirectly also criticize God.
Your Holiness, would you say that there's a differential benefit to ourselves in these two different kinds of compassion? That is, the first kind, which is more in the mother-infant context, that is more, you say, more biological, more limited.
And compassion, attachment. Yes, attachment,
yes.
no.
Versus being able to express compassion toward one enemy. Is there more benefit to us to be able to, with training, to be able to express compassion to the enemy?
Of course. Usually our disturbance come from our enemy, not from our friend. So once you see those thoughts, which we really get is the disturbances. Once your attitude change towards that, then there is nobody creates a problem for you.
Your Holiness, how do you think about these people that I described who were incredibly altruistic, risking their lives for months or years? How do you, and not trained at all particularly, they just had this as part of their essence. When you think about people like that, what do you think about from a Buddhist perspective?
There are individuals who are very, naturally compassionate and altruistic.
I think among animals also, I think sometimes it happens. I think that because of Rimba. Differences. They are like these among the birds, among the animals. I think some parent stronger sort of concern about their offspring. Some less. So now, again, now we cannot explain biologically, purely from biological. Now our sacred concept of karma. Maybe.
Okay, it's karma, right.
Because of the previous life, because of impact. So among the human being also, we believe like that. Those people, this lifetime,
Yeah.
irreligious, no religion,
No religious,
no faith. But even you see the previous life also is not necessarily a religious person, but somehow more compassionate. So next life,
So this is one of those effects that are of similar kind.
Yeah, that's what I would think.
Something like within lifetime, at the beginning, you find it difficult, you see, to do that. But familiarization, right?
Through cultivation of familiarity.
These great scientists at the age of 10 or 15, see, these subjects comes, very difficult, isn't it? Yes. Training, learning, experiencing. Then now, you see, you find these are easy. That's because of the kasure. I think our biological, not kasure, 당분은 biological.
So, the knowledge that you have gained as a scientist did not come, naturally as a result of biological constitution. It was a cultivated knowledge.
But through training, get used to it. Then these things, this difficult subject, come in your mind very easily, almost like spontaneously.
Mm-hmm.
That's because of the komba.
Habituation.
So you think these people must have trained in a previous life? To have
Yes. Some traces
you don't think
of that.
Yeah, genetics might not explain. It's hard to think about how genetics would lead to.
Might be difficult.
And of course, environment also is for temporary, immediate, temporary, because immediate environment influence also there.
Earlier, I was suggesting to His Holiness that with respect to the critiques of this study, part of the problem may be something to do with the very uniquely Western cultural understanding of what compassion and altruism means, because there is a very strong notion in the West that when it's altruistic activity, it has to be totally self-sacrificial act. There needs to be no benefit at all to the performer of the action. And there is this real dichotomy between self-interest and others' interest, and true altruism should not have any benefit at all to the person who is committing the act. Once you have that kind of dichotomy, extreme, sharp break, then it's totally impossible to bridge the gap.
It's our Puritan ethic that leads.
So whereas in the Buddhist understanding of compassion, there isn't that dichotomy. So just
Matthew wants to make a comment specifically about this.
It's directly linked with that, because you see, I think that criticism doesn't hold because you cannot separate, compassion with a feeling of well-being. They are so interestingly enmeshed because compassion and altruism are the most positive of all positive emotions. So either you express them or not, but if you express them, you are bound to have an increased well-being. So the reason being that a selfish happiness doesn't exist. It's a lose-lose situation. You might wish to achieve happiness through very self-centered and motives and at the cost of others' suffering, but in the end, you are going to be tormented yourself and you are going to inflict suffering on others. So it's a lose-lose situation. So now, if you do develop altruism and altruistic love and compassion, and then of course you become a more benevolent person, which everyone will appreciate. At the same time, this is the major root constituent of genuine well-being or sukha. So you cannot diss them out. So this is a win-win situation or a lose-lose one. You cannot have a triumphant, really deeply fulfilled, completely selfish and making everyone happy. He can have a temporary satisfaction, but not a genuine happiness.
Yeah, I think it would be helpful also to introduce the notion of guilt and the notion of time, of having a future. And that may be the reason why true altruism probably occurs only in human societies, because animals have neither. Maybe dogs sometimes feel guilty, but usually animals don't, and they have no notion of their own lifespan. And we humans, we sense very well that if we omit help in a particular moment of time, and we may even have experienced this, that we feel bad for a long time. And there are situations, and I think this is partly the case with these helpers for the Jews, that these people feel that if I omit help now and sacrifice this Jewish family, I will never be lucky again throughout lifetime. And then they are ready to sacrifice themselves rather than going through this tormenting life, because human subjects can kill themselves. So there are privileges that we have that are necessary ingredients for altruism.
그래서
간다
교배서
교바다 투기 전에 교바면서 간다 지심진이 나리야 수수 미세 마음 바삼다 이제 제동에 된 미마도 말이야.
And that may have a lot to do with the changes in the prefrontal cortex over the course of evolution. It's larger in humans than in other species, which allows us to anticipate the future in the ways that Wolf was describing. Paul, this is the last comment, because then we'll have to break for lunch.
I'm going to raise these issues this afternoon and return to the study that Ben mentioned and talk about some of the research questions it raises. But I do think that we have to also consider here the fact that humans have a sense of self. And very often
Good morning, Your Holiness. We began the week with quarks and quanta and qubits and entanglement, and then we moved to cosmology. Yesterday we spent the day on consciousness, and today we will move to focus on evolution, and we will revisit the issue of randomness as it comes up in evolutionary theory. And we'll then also move on to the topics of altruism and compassion, which Your Holiness has underscored as so, and emphasized as so important. We're very fortunate to have Ben Shapiro with us. Ben is a board member of the Mind and Life Institute and is a biochemist and a physician by training. And we'll begin this morning by talking about evolution and randomness and how it may be related to altruism. So with that, I turn it over to Ben.
Good morning. Good morning, Your Holiness. Yesterday, Wolf Singer gave a beautiful talk and told us about several things. He told us about consciousness, but he also told us about the use of evolution as an absolutely fundamental part of the infrastructure in thinking about any aspect of life. And we believe that that is a key component that our knowledge of life is built upon. As a key component, we want to be sure that it is a strong part of our foundation. And thus it's appropriate to see whether this foundation can deal with all the issues that we learn about as we study more about the living state. And for that reason, I was delighted to read in your wonderful book, chapter on evolution and karma and sentience, because you raised several points that we need to think about as biologists who seriously want to pursue this model. And I'm delighted to have the opportunity to respond to several of the points you made, because I thought they were so important. And I consider it an honor and a pleasure to have the opportunity to do that. Anything that we talk about in the environment of evolution, I think needs to be approached with this perspective that you gave in your book. Whether we see ourselves as random biological aspect of this, in its overall function has been supported. So although we speak of a theory of evolution, we also have a theory of gravity. But everyone knows what's going to happen if I open my hand. So consequently, we probably understand evolution better than we understand the mechanism of gravity. So it's a theory in the sense that we keep understanding new issues about this, we're refining it, and refining it in light of some of the questions that you raised. So let me go back now to your first question. Can variation really be random? And to discuss this, is mutation really going to be a random process? Or is there some type of hidden causality? This phrase, hidden causality, was extremely provocative in several senses. It was it's provocative in an interesting sense, in that it certainly made me, and I think other people, think about what types of issues might be in biology around the idea of hidden causality. In a less serious sense, in a more bizarre sense, it was provocative of behaviors in America that I want to tell you about briefly. In America, we repeatedly encounter interactions between people who feel that their lives have been damaged by the fact that that Darwinian evolution says there's no need for a creator God to have made them in God's image. And so Darwinian evolution has no need for the hypothesis of a creator or a creation. Some people interpreted your phrase here to indicate that you might have thought that there was a need, that this hidden causality meant some creator in the background. This, of course, is a ridiculous idea because it's against everything in Buddhism. It's against everything you said in your book about where you dealt with the issue of a creator. But yet, reviewers of your book referred to this in the sense of who is behind the scene pulling the wires, and His Holiness, who believes that science is preeminent, is suggesting something like a creator force in the background. And Mathieu was contacted by people from the so-called intelligent design movement who wanted him to sign a petition, since it looked like Your Holiness had supported the idea of there being some intelligent designer up there pulling the strings, and they thought they could get support. Creatures, or as special beings endowed with consciousness and moral capacity, will impact on how we feel about ourselves and treat others. We are doing this activity to relieve suffering, and it's important that we keep this in mind, especially when we talk about evolution, because ideas of evolution have been used to support many types of behaviors, some of which have spread across the political spectrum, across the social spectrum, and in fact, as much as it has provided information and support for our understanding of biology, certain interpretations of evolution have increased suffering for certain people because of the issues that were put on the table. So this is an extremely important area. This is the one grand theory of biology, and we have to see whether this theory is appropriate. And your challenges, I think, were, to me, very, very much on point. So I want to talk about the two qualms that you raised. The first one, the two reservations you raised. The first is about completely random mutations providing the variation needed for evolutionary change. And you say, from a philosophical point of view, the idea that these mutations, which have such far-reaching implications, take place naturally is unproblematic. But they are purely random strikes me as unsatisfying. It leaves open the question of whether this randomness is best understood as an objective feature of reality or as indicating some kind of hidden causality. It's a very... And this reservation deals with one of the central pillars of evolutionary theory. The creativity in evolution is the variation that comes about by mutation. That is what leads to all the opportunities that exist. And I think we need to consider what is the essence of that mechanism and to think seriously about points that you raise such as this. The other reservation, the other qualm you had was about natural selection and competition for reproductive success being the driving force for evolution, and the inability of that to explain altruism. And you said the inability or unwillingness to fully engage the question of altruism is perhaps the most important drawback of Darwinian evolutionary theory. Why does modern biology accept only competition to be the fundamental operating principle, and only aggression to be the fundamental trait of living beings, since humans have a dangerous tendency to turn the visions we construct of ourselves into self-fulfilling prophecies? A very important point. And this reservation deals with the other central aspect of evolution. If mutation is the creative part of the process, this is the editing part, the part that determines what ends up in any pathway of evolution. And here you're raising a fundamental challenge that says that maybe this doesn't apply in every area. Maybe we can't use this as our foundation in this area. These are very important points. First, I want to say a word about natural selection. There's no question that selection works. I mean, we know that just by recognizing that starting with a wolf, in hundreds of generations, we have generated many different types of dogs just based on human interest in mating animals to achieve a result. And so there are all kinds of dogs, many of whom we heard last night at 4:30 in the morning in Dharamsala. But nonetheless, in any event, clearly selection works. The question is, what is the domain in which natural selection can work? So I'll come back to that, and I'd like us to look at to step back from the biologic aspects of Darwinian evolutionary theory and look at it as an abstract concept, because I think that's a useful place to start. Darwinian evolution is really an optimization hypothesis. And it deals with the So it deals with the fundamental idea that if the environment changes, there are new causes and conditions. How does one adapt to this new causes and conditions? What can one do to be appropriate in the new environment? And you can imagine two extreme ways of dealing with this. One way would be to take the best intelligence that there is, optimal intelligence, and take the best ideas and design the best system for this new environment. And that would be one extreme. And another position would be to say, really smart. Pick the best way to go. And that's a reasonable way that one might do it. Another reasonable way would be to say, I don't understand everything about the new environment. It's a complex environment. It has many causes and conditions. And so, because I don't understand it, I can't make the best thing. I will make as many things as possible. Test them out. See what works in that new environment. These are two general ideas about how one might approach change. It turns out that Darwin, in looking at what had happened in the previous century of biology and of study of fossils, and from his own careful observations of the geography of animals and aspects of development, Darwin said, what happens is really number two. This is the path that biology has taken, that there's variation that occurs, and then these variants are tested in the new environment. This, and this was actually an amazing idea, because in a sense, this was done in the absence of everything we know today, 150 years later, about biology. He didn't know anything about genetics. He certainly didn't, because Mendel hadn't done his experiments for 2 decades, and Mendel's experiments on genetics weren't really appreciated until the beginning of the 20th century. It was 100 years later before Watson and Crick discovered the structure of the gene. And now, 150 years later, we know much about gene sequence. Francis Crick, the co-discoverer of the gene, said, evolution is cleverer than you are. We have no need for this hypothesis, the first part of the hypothesis. That is not necessary to explain what happened in biology. That is extremely important. And we don't need to look at the fossil record or at animals themselves or the development of animals. We can look at all of those. We can look at the genes in the animals and see the relations that exist between all living beings. It is remarkable to me that Darwin put in place this fundamental idea that has been supported by 150 years of biology and genetics and every